Let's talk about nutrition and performance. And I must admit, whenever I teach about nutrition, I always end up feeling really hungry. So let's start off with some sort of obvious places. First of all, let's just think about calorific intake in a particular day. What we'd expect is, on average, males, I should say, perhaps, will experience something like 2,500 kilocalories per day. Okay, so that would be a pretty typical figure. Now, just be aware that kilocalories, that we've got a convention of just calling them calories, but in fact it's 1,000 calories. Okay, so just be aware of that. And secondly, women tend to take on slightly fewer calories on average per day, so in the region of about 2,000 kilocalories. But remember, these are averages. Don't take them too literally. It depends on all kinds of factors, and there are many cases where women, of course, will take on more calories than men for good reason. Okay, so there's a reason for that. Now, I also want to address for you, before we get into sort of the meat of this, I want to talk to you about energy balance. All right, energy balance. And it's a really very simple concept, and it is this concept. Energy balance says the following: that if we achieve energy in, when we're talking about calorific value here, if energy in equals energy out, effectively what we use in metabolic processes, energy out, then what that's going to mean is that somebody is going to experience stable weight. All right, so if you yourself are someone with stable weight over time, it means that on average, the amount of energy you take in through your diet is equal to the amount of energy that you spend or that you use through the various metabolic processes and the movements that you actually occur. Now, all that's great. What I want to spend the rest of this tutorial talking about is what we might call macronutrients. And I'll come back to these images in a few moments' time. But really, I want to introduce the idea of macronutrients. Okay, I don't know if there's a term that you'll necessarily use or write about, but I'm just going to use it for sort of summarizing what I'm talking about here. And I want to talk about macronutrients in the form of three things. Okay, one, we're going to talk about carbohydrates. Okay, so we'll come to that in a second. Carbohydrates. And by the way, I'm very aware that you'll be studying different substrates in your biological study. You're probably very aware of the insoluble nature of these and how they're broken down through digestion to become soluble, how they're absorbed in the small intestine. You're probably aware of this, right? But just be aware, I'm going to sort of skim over some of that. Secondly, our second macronutrient we're going to talk about is fats, or I'm going to immediately refer to them as fats or lipids. Again, something you're probably studying in a bit of detail in your biology. And finally, guys, we're going to have a look at our third macronutrient, which is protein, those chains of amino acids. And again, we'll come back to that in a few moments' time. So let's have a think about this. Let's go to our carbohydrates. What are they and why do we need them? Okay, and we'll think about it in relation to performance as well. Well, first of all, they are a form of energy, of course, chemical energy. That's what they are for. And they are broken through our digestion. They are broken into small soluble sugars. And a great example of these would be something like glucose. Okay, glucose, and you probably want to reflect that glucose, of course, is one of the reactants in both anaerobic and aerobic respiration. So we can derive glucose from carbohydrates. Now, as I said before, they are absorbed in the small intestine. Now, when I say they, I'm talking about our glucose, for example, absorbed in the small intestine. Now, I'm not going to get into the details of the small intestine here. I reckon you probably know about the villi and the microvilli and the walls of the intestine. Let's leave that for another time, perhaps another subject, but there we go. A couple of other things about carbohydrates. They can be stored, okay? So that's interesting, isn't it? We can take carbohydrates on board and we can store them. And we can store them in the muscle and we can store them in the liver, okay? So our carbohydrates are stored in both the muscle and the liver. Now, the only thing I'd add to that is that the liver is the major store. But this is important, guys. The store is limited, okay? We call it a limited store. Now, what do we mean by that? In essence, what we've got there is we've got 2 hours worth of stored carbohydrates. It's actually in the form of what we call glycogen. Let me write that in here. Glycogen is the format in which it's stored. Okay, stored glycogen in the muscle and the liver. But we've only got about 2 hours worth of it. Now, as I said before, it is the fuel or the reactant for both for both anaerobic and aerobic exercise, or anaerobic and aerobic respiration. Anaerobic and aerobic. Now, just distinguish in your own mind the difference. Let me put respiration in there. Anaerobic and aerobic respiration. Just distinguish in your own mind the difference between those. Aerobic respiration takes place in the mitochondria. It's glucose plus oxygen goes to CO2, water, and the release of energy. Okay, whereas anaerobic is that glucose goes to lactic acid plus a release of energy, and it's not in the presence of oxygen. So it's really important to stress these points. And finally, guys, we should just be aware that we have different types of carbohydrates. They can be both complex and simple carbs. More complex carbs, long chain carbohydrates, would be things like whole wheat carbohydrate, things such as brown rice, whereas simple carbs would be things like sugars, let's say fructose from fruit or lactose from milk. That's what we're talking about. So that's what our carbohydrate provides us with. Now reflect on that. That's actually really important for a sports performer, but not least because energy is the central feature. Now fats and lipids, they're bad, right? Well, hang on a second. They also are a source of energy. It's really important. And they are broken, as we talked about our soluble sugars here. Our lipids are broken into soluble, do you know what's coming next? Soluble glycerol, and fatty acids. Okay, in fact, we get 1 glycerol and 3 fatty acids from each lipid. That's fatty, believe it or not. Fatty acids. I don't know if you're interested, guys. I'll just draw what a lipid would look like. We get a block of glycerol, and then we get 3 fatty acid tails like this, and we can break it down into those different components. Okay, and then they become soluble. We can take them on board. That's exactly what we're looking to do. We again are absorbed in the small intestine, so I'll just put small intestine. This is where we absorb them, exactly as we did with our sugars, our carbohydrates earlier on. And interestingly, we can also store them. Now think about where we store them. We store lipids, we store fats, we store not in anything, we store them stored under the skin. Okay, so if you think about that sort of fat store under the skin, look, I've got plenty if I'm completely honest, that is ultimately a form of stored energy. It is a potential energy store if you want to think about it in terms of your physics. Now, we should also be aware that we do have what we describe as some good fats. Okay, some good fats. So by good fats, we're talking about things which are typically plant-based. Okay, so there are a couple of exceptions to that, especially from fish. They're also, as I just said, from fish. We would say that good fats are what we refer to as an unsaturated. I'm not going to get into what unsaturated and saturated means and the differences in the different kinds. I'll leave that for another day. But we'd also be talking about things like omega-3, which is only available in a few products, particularly oily fish. But we also have what we'd call bad fats. These are things really to be avoided that can cause all kinds of issues, such as blockages in arteries. They can cause a high cholesterol. But bad fats, generally speaking, will be animal-based, okay? Especially from sort of red meat type environments, and things like saturated fat. And just look out for words like trans fats. I'm not going to get into them here, but these are things to be avoided. So just be aware that we have good fats and bad fats. Now finally, with our proteins, guys, just first of all, they give us a very small amount of energy, not very much, but they do provide a little bit of energy. What their main job, however, is for growth and repair. So you can think about this in all kinds of ways, a child growing into an adult, but perhaps more importantly, think about it in terms of the growth and repair and the adaptation process in fact, let me write that in, the adaptation process. So if we do brilliant training over time, we have physiological adaptations and changes. That's the adaptation to this. Now, we have our proteins are broken down into, and I wonder if you know what's going to come next, amino acids, okay? Now, I'm not going to get into amino acids. That's a hell of a long conversation, but I'd really encourage you to reflect on these in relation to your biology studies. You probably know that amino acids, we need to break them down to inject, to effectively to make them soluble and therefore to take them on board. But we rebuild amino acids into other proteins in other forms. It's actually fascinating. Again, we absorb these amino acids where? In the small intestine. I mean, if you want to get really specific, by the way, guys, you could talk about the first part of the small intestine, the duodenum, if you really wanted to. But really important, this point, the amino acids we take on board, they form other proteins. So we use these amino acids to form other proteins, such as hormones and enzymes. It's really important. And finally, guys, I didn't mention it as we started. I should have spoken briefly earlier on about fiber. Let me put it down as number 4, fiber. Okay, so let's just mention fiber for a second. Fiber is what we'd call insoluble. Remember that insoluble means that we can't absorb it into the bloodstream. So what this does is it aids digestion, and we tend to get fiber from things like plants generally, and it's really good for what we'd call gut health. Okay, so good fiber in the diet is really important. Now, final things from me. Where do we get carbs from? We get carbs from, let's go up here. We get carbs from bread. We go to here. We get carbs from bread. We get carbs from certain vegetables, such as potatoes we've got in here. We also get it from rice. Where do we get fats from? Well, we get fats from meat. We get them from nuts and pulses. We get them from oils, from fish, as we've mentioned before. Where do we get protein from? Definitely from fish, definitely from meat. And again, beans, pulses, we get lots of protein from there as well. Fiber, really important, we get fiber from our vegetable-based diet. That's all from me.